Okay, ladies and gentlemen. Okay, let's quickly work through these 4 examples. In my experience as a math teacher, the biggest problem for me is not the differentiation part. It's manipulating the expression to such a point where you can actually differentiate. That's where most of you guys completely fall out of the bus. Okay, so if I were you, I would maybe, before your exam, go and grab a grade 10 textbook. Yes, for instance, how do I simplify fractions? How do I simplify exponents? Because that's where you guys struggle. It's not the grade 12 work. The grade 12 work is easy. So let's start with question A. Y equal to 2x squared minus 1 over 3x. In my experience, this is what a lot of you guys write down. Okay? Now, if I was an examiner in your exam, prelim, I would write this and ask you, find the mistake. Because that's what we love to do. What is the problem here? The problem is the 1/3 must stay in the denominator. Because I don't care about a number in the denominator. It's just the x may not be in the denominator. So I leave the 3 in the denominator, and now I differentiate. So this is 8x minus, and a minus is a plus 1/3. 1 times 3 is 1/3. And I subtract 1, so it's -2. So this gives me 8x. Just make your exponent positive, please. So do I have to do that? No, not really, because I didn't say to you, determine dy over dx and simplify. But please, those guys listening at home as well, just keep your teacher happy. Because some teachers might go and say, but you're never allowed to leave your answer with a negative exponent. Even though they didn't outrightly say that, please just keep your teacher happy. Okay? End of the year is a different story, but please keep your teacher happy. You need the marks. Okay, so let's look at B. If I look at question B, the issue for me is number 1, there's roots and x's in the roots. So what am I going to do? I'm going to apply the exponential laws. And now, as I said to you, sir, now you have to go back to grade 10 and ask yourself, how did I handle fractions where there was one thing in the denominator? For me, the easy thing is to split up. To go 2x to the half over x to the half minus 5 over x to the half. For me, that's easier. So this gives me 2 minus 5. Oh, that is an ugly 5, that. X to the negative a half. Another option could be, but you've got to be careful, 2x to the half minus 5, x to the negative a half. So I take this thing up, make it negative, but I've got to distribute this now in. And if I multiply the same basis, what do I do with the exponents? Add them. You guys starting to see why everything leads towards differentiation? And why you've got to know all your rules and all your laws? Remember, we're allowed to ask you anything in your high school career in this chapter. I'm just putting it out there. Not good news for all of you. So dy over dx will be positive because I'm multiplying to the front. So 5 over 2, x to the negative 3 over 2, which again, I'm just going to simplify x to the 3 over 2. So taking it into the denominator, x to the power of 3 over 2. If I now look at question C, one of our fan favorites, question C, xy minus 5 equal to root x to the 3. Now, I just want to quickly say this. For those of you that have AP Maths, you should be able to do these by using product rule, quotient rule, chain rule, implicit differentiation. Oh, yes, I forgot that one. This one I would expect you to be able to do by using implicit differentiation because y is not the subject. Okay? But for the rest of us normal people, okay, I can't go towards dy over dx because y is not the subject. So I first have to get y alone. So it's going to be xy equal to 5 plus x to the power of 3 over 2 equal to 0. No, man, where's the equal to 0? Sorry, I'm half asleep. Yeah. Divide by x, divide by x, divide by x. Y is equal to 5 x to the negative 1 plus x to the half, because I'm dividing those, so I'm subtracting the exponents. So therefore, dy over dx is going to be equal to negative 5x to the negative 2 plus a half x to the negative a half. Okay, I'm going to be that teacher now. Busihle was writing an exam. And that was their attempt at determining the tangent to this specific graph. Busihle is telling you that this answer is the equation for the gradient for x, an element of real numbers. Woo! So this is the gradient for x, an element of real numbers. Now the question in the exam says the following. Identify Busihle's error in the statement. So please, don't be that person that says, there's no mistake, sir. There is a mistake in her statement. Her statement says it's the gradient for x, an element of real numbers, that dy over dx. Whom of you, by show of hands, and let's be honest, is going, but sir, there is no mistake? Be honest, come on. Now you're in a catch-22 situation here. Because if you're telling me there is a mistake, I want to know what it is. Say again? Well, it is the gradient for, I'm saying that is the gradient for all x values. So that is not the specific problem, the x and the y. But there is a mistake, and I'm telling you guys, be careful. You guys are there's the English word called flippant. And that's not a bad word. It's more you guys are almost nonchalant. In other words, now again, big words, meaning, yes, I've got big words in my vocab today. Guys, you guys are almost careless because you guys just do things without thinking. I want to take you guys back up in the sum and ask you guys, by what did I divide here? I divided by sunshine? By what x value am I not allowed to divide with? Oh, I'm not allowed to divide by? So this can't be the gradient for all x values because, very important, x may not be 0. So it can't be the gradient for all x values. It's the gradient for all x values except 0. You've got to be careful the moment you divide by a variable. Because if you're dividing by 0, the whole thing is undefined. That's why I'm saying you guys are sometimes very careless. You just go for it, man. YOLO, I'm just gonna go for it. Let's worry about the repercussions tomorrow. Okay, so ladies and gents, let's go towards D, our last short differentiation for today. Y is equal to x to the pi minus 4 root 2x plus t. I chose this sum for 3 reasons. Because of the pi, it completely freaks some of you guys out. Pi is just a number, a very special number. Secondly, I put the root 2 and the x both in the variable, or in the root, I mean. So this is x to the pi minus 4 times by 2x to the half plus t. What is my mistake? Okay, thank you very much, guys. The 2 was also in the root. Let's not discriminate, please. Am I going to take it and say 2 to the power of a half? I don't have to, because root 2 is again just a special number. Now if I differentiate, and again, I can make a whole scenario up about Busitle. And if I differentiate this, I get 2 root 2 x to the negative a half, and then I go plus 1, and I ask you, what is the mistake? That plus 1 shouldn't be there, it should be plus. It should be plus 0. Okay? Why is it plus 0? Because I'm differentiating towards x. So t is a constant value. As long as we assume there's only 2 variables, x and y. I want to ask you guys the question. What is the value of dy over dt? What is the value of dy over dt? 1. Why is dy over dt 1? Because now x is a constant. So that whole thing is a constant. So if I differentiate it, it becomes 0. If that is a constant, this whole thing is a constant. If I differentiate it, it becomes 0. So I'm actually only left with differentiating this back t, and it's just 1. Be careful of the way we write it, because I can already see for 1 mark asking my students from here, give me dy over dt, and they go manipulate the living daylights out of this thing, when I actually then only look at the dt, at the t being differentiated. So you've got to be careful which variable you're working with. Please, 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 please be careful.